here are the basic rules of exponents. So an exponential expression is in the form a to the m. So here a is called the base and m is the exponent or power. Now the first rule of exponents is a to the m times a to the n is a to the m plus n. So if we are multiplying two numbers with the same base, which is a, then the answer is a, which is the base, to the sum of the exponents, which is m plus n. So for example, if we have 2 cubed times 2 squared, 2 cubed is 2 times 2 times 2. That's the definition of 2 cubed. 2 squared is 2 times 2. Now the result is the exponential expression, which is 2, which is the base, to the power of 5, 2 to the 5th power. Now, basically we had 3 of these 2's multiplied together because that was a 2 cubed. We had 2 of these 2's multiplied together, which was 2 squared. So when we put them all together, when we multiply them all together, we have 5 of the 2's. So that's how we get the 2 to the 5th power. We can think of this 5 as 3 plus 2. 3 of the first and 2 of the second. So there's a total of 5 of the 2's multiplied together. So that's 2 to the 5th power. Now the second rule is the rule of division, which says a to the m divided by a to the n is a, which is the common base, to the exponent, which is the difference, m, which is the exponent of the numerator, minus n, which is the exponent of the denominator. Now look at the example, just to get an idea of why there is subtraction. So if we have 2 to the 5th over 2 squared, 2 to the 5th is 2 multiplied by 2 multiplied by 2, so on. 5 times 2 is multiplied to itself, divided by 2 squared, which is 2 times 2. Now remember the rule of cancellation. A factor in the numerator can be cancelled with a factor in the denominator. And we are left with 2 cubed. So out of the 5 2's that were multiplied together, 2 of them got cancelled and we are left with 3. In other words, we can get this just by going 2 to the 5 in the numerator minus the 3 that get cancelled. So that's, minus the 2 that get cancelled because that's a 2 squared. And that's how we get the 2 cubed. The third rule of exponent is a to the m whole to the n is a to the m times n. So if we have an a squared the whole cubed, anything the whole cubed is the same thing multiplied with itself 3 times. So it's a squared the whole cubed. A cubed is a times a times a. A squared the whole cubed is a squared times a squared times a squared, which is a to the 2 plus 2 plus 2. So 2 plus 2 plus 2 is 3 times 2, which is equal to 6. So that's how we get the rule m times n, which is a to the m times n, which is a to the mn. So if we have a to the 5th whole to the 3rd, it is just a to the 5 times 3. Now the last rule is ab to the n is a to the n, b to the n. Let's look at an easy example here. ab the whole cubed, anything the whole cubed. A cubed is a times a times a. So ab the whole cubed is ab times ab times ab. There are 3 a's multiplied together. We are allowed to rearrange because it's multiplication. So that's a cubed because there are 3 a's multiplied together. A times a, which is a cubed. B times b, which is b cubed. So basically, each gets cubed. Now let's look at a few quick examples. Suppose we have x to the 4th, y to the 6th, x cubed, y to the negative 2. So this is example 1. So here we can rearrange and think of this as x to the 4th, x cubed times y to the 6th, y to the negative 2. If the bases are same, we write the same base. So these two can be combined using the first rule. 4 plus 3 times. So here again the bases are same. So these two can be combined to write it as x to the 6 plus negative 2. We just add the exponents. So that is x to the 7th times, sorry, that should have been a y to the 4th power. So the y's combine. Y to the 6th times y to the negative 2 is y to the 6 plus negative 2, which is 6 minus 2, that is 4. Now suppose we have x to the 4th, y to the 7th, z to the negative 3 divided by x cubed, y to the 9th power, z to the negative 4th power. Now here, remember, the rules work only if the bases are the same. So these two, the bases are the same. So x to the 4th divided by x to the 3rd is x to the 4 minus 3. Bases are same. Now y is the base, so it's y to the 7 minus 9. So division of terms with the same base, exponential terms with the same base, we subtract the exponents. Numerator, exponent of the numerator minus the exponent of the denominator. Now z, negative 3 minus negative 4. So this is equal to 4 minus 3, which is 1, y to the 7 minus 9, which is negative 2, z to the negative 3. So this is negative 3, negative times negative is positive 4, so that is z to the 1. Negative 3 plus 4 is equal to 1. So this is equal to x, y to the negative 2, z. Now remember that if we have y to the negative 2, we can write that as y to the negative 2 over 1. We move the y to the negative 2 to the denominator and we get y to the positive 2. So if we want to change if we want to write everything in terms of positive exponents, we write it as xz over y to the positive 2. So that's xz over y squared. Now suppose we have x squared y to the 7th divided by x to the 5th, y to the 3rd. Let's even add some numbers here, whole squared. Now remember a to the m, ab to the m is a to the m times b to the m, right? So that's what we're going to do eventually, but parentheses first. We're using PEMDAS, so we work on the parentheses first. So inside the parentheses first, so we have x squared divided by x to the 5th, so that is 2 over 3 x to the, and remember that x is in the numerator when we use the rule of division of exponential terms with the same base, and y can be simplified to, so these two combine, 7 minus 3, and I can worry about the whole square at the end once I've simplified the expression. So basically what we do is we work inside the parentheses first, make sure everything is simplified inside, and then finally we use the other rule. So 2/3 x to the negative 3, 2 minus 5 is negative 3, y to the 4th power, the whole squared, and that is equal to 2 squared. Each one of these gets a square. So that's 2 squared times x to the negative 3, the whole squared, y to the 4th, the whole squared, divided by 3 squared. So that is 4 over 9, x to the, remember the rule, a to the m whole to the n is a to the m times n. We just multiply the exponents. So that's negative 3 times 2, y to the 4 times 2, and that is 4 over 9 x to the negative 6 y to the 8th power.